Hello everyone, welcome back to my YouTube channel. This is Rachana from Sri Venkateshwara College of Engineering pursuing second year. Today in this video we are going to discuss on the topic improvement of multi-channel LoRa networks based on distribute joint queuing. So first we are going to discuss on the topics abstract, introduction, literature review, architecture model, methodology, results, and lastly conclusion. So first, let us see the abstract. Long range has gained popularity in realizing Internet of Things applications by facilitating long range communication with power consumption. In contrast, distributed queuing, a collision free, contention based RA protocol, is a promising candidate for replacing alpha because of its near optimal performance and independence from the traffic load and pattern. Our analysis shows that the proposed protocol reduces the control overhead by up to 70% compared to DQ. The protocol performance demonstrates near optimum throughput and access delay irrespective of the number of arrivals. This is the queue data structure. Next, let us move on to the introduction. Recently, low power wide area networks have emerged as solutions to specific requirements of Internet of Things IoT applications, which include small data, several bytes transmissions such as for monitoring, telemetry, and remote control. The simple strategy reduces the complexity of network deployment. However, the packets often collide and the transmission is blocked in dense networks. In contrast, distributed queuing, a contention based RA protocol that ensures collision free transmission, is often referred to as promising candidate for using LPWANs. DQ can flexibly cope with unpredictable traffic patterns. It behaves as an RA like protocol in a sparse network and as a scheduling like protocol when the network becomes dense. However, adapting DQ to local area networks is challenging for two reasons: the contention overhead and multi channel access. Numerous studies have been conducted to adopt DQ in wireless networks. Among these, DQ LoFTA and DQN, and the latest studies that modified DQ for LoRaWAN. DQ LoRa attempts in to eliminate empty data slot frames only if there are no successful collision resolution stations during the contention phase. Next, let us move on to the review. Queuing theory applications. Queuing theory remains essential in analyzing network performance. Kumar et al. 2023 applied advanced queuing model to investigate the impact of different queuing strategies in LoRa networks. Next, distributed queuing approaches. The benefits of distributed queue management have been further validated. Ken et al. 2023 developed a decentralized queuing framework, especially the LoRa networks, which allowed for local decision making and load balancing. Next, what are the future directions? Emerging trends suggest integrating advanced analytics and AI into network management. Gain et al. 2023 proposed a novel framework combining predictive analytics with distributed queue management, aiming to optimize resource allocation dynamically. Next, what is the architecture model? Queue management system. In these two types, distributed queuing and dynamic channel allocations. In distributed queuing, each gateway maintains local queues for incoming messages, allowing parallel processing and reduced delays. Implementing algorithms that prioritize messages based on urgency and application needs. Next, dynamic channel allocations. Algorithms for real-time channel assignment based on queue lengths and channel conditions. Enable nodes to switch channels dynamically to avoid confusion. User interface. Management dashboard. Visual representation of network health queues, status, and channel usage. Allow network administration to make informed decisions on configurations. Next, network layers. In these three types, physical layer, data link layer, and network layer. In physical layer, manages the transmission and reception of data over multiple channels. Next, data link layer handles channel access, including medium access control protocols optimized for distributed queuing. Network layer manages routing and ensures efficient data transfer between devices and gateways. Control mechanism, feedback loop, continuous monitoring of channel conditions, queue lengths, and transmission success rates. Adjustments made to channel allocation and data rates based on feedback to optimize performance. Interface detection, system to detect and mitigate interference from external sources, other networks. Next, what are the methodology? Queue management strategies. In this distributed queuing framework, implement a decentralized queue management system where each gateway processes messages independently. Prioritize messages based on criteria such as urgency and required delivery time. Feedback mechanism. Establish a feedback loop where gateways share information about queue status and channel conditions to optimize performance. Real world implementation. Pilot deployment. Select a real world application, example smart city agriculture, for pilot development. Deployment. Set up a limited scale LoRa network with a developed queuing and channel allocation strategies. Data collection. Monitor network performance in real time, collecting data on throughput, latency, and packet delivery rates. Next, what are the results? The results demonstrate that the proposed enhancement to multi-channel LoRa networks, specifically through distributed joint queuing and dynamic channel allocation, lead to substantial improvement in performance matrices. These findings confirm the effectiveness of the methodology in optimizing communication efficiency and reliability, making the LoRa networks more suitable for diverse IoT applications. Future research will focus on further refining these strategies and addressing identified limitations to ensure robust performance at scale. Next, what are the references? R. Furness, R. Oliveira, M. Lewis, and S. Sargento on the real capacity of LoRa networks, the impact of non-destructive communication, IEEE communication led. A future J. Pucho and Oliveira, Physics Mac, Unlinked Performance of LoRa Class A Networks, IEEE Internet Things. D. Salja, R. Singh, L.K. Bagel, and S. Kumar, Scalability Analysis of LoRa Network for SNR-based SF Allocation Scheme, IEEE Trans Informate Volume 17, Number 10 pp. These are the references for this paper. Lastly, conclusion. This study demonstrates that improving multi-channel LoRa networks through distributed joint queuing strategies significantly enhances network performance and reliability for IoT applications by implementing dynamic channel allocation and efficient queue management was achieved substantial improvements in key performance matrices, including throughput, latency, and packet loss rates. Overall, this research contributes valuable insights into the design and implementation of effective communication strategies in LoRa networks, paving the way for improved applications, smart cities, agriculture, and others IoT driven domains. Thank you everyone. If you like this video, please do like, share, and subscribe. Thank you everyone.